Hello, this is Dr. Arberg. What I'd like to present in this video is the process of training an exoskeleton to do its job. What we see here is an exoskeleton that is being trained to walk as long as possible without violating the limitation, which is imposed net. At the same time, keeping the motion safe by keeping the center of gravity in between the 2 feet and making it as comfortable as possible to the user by keeping the stop forces as low as possible. What we see here is close to 3,000 iteration. It took quite a few hours to get there. It started with a reward of minus 200 points, and it gradually went up and down, oscillated, tried different strategies, and finally it got to a solution here where the optimum seems to be a steady slight incline backwards of the torso posture. As we see here, the torso is not oscillating. When we looked at it yesterday, we saw over here, a few thousand earlier, then the solution seemed to be a slight oscillation in sync with the footsteps. And as time went by, learning progressed, we see that a different solution got achieved with a higher score. This is the actor estimated total reward for an episode, and this is the critic, which is grading the actor with its total estimate. And it seems that at the end of the training, the two of them will converge, because the whole process of reinforcement learning is to minimize the error between the two. Now, if you take a closer look at what the program is doing here, we have a MATLAB program that has 3 sections to it. This is the main program, which actually does the reinforcement learning process. And it all starts with the definition of the observations. In our case, we took the observations to be the forces at the stops, as well as the motion, the random motion of the user. In this program, we define the random motion of the stop and the user. The action in our example is the reinforcement learning forces which are applied, or torques which are applied to the system in order to change the posture of the torso, as well as the angles of the joints. So this is on top of a PID control, which is very robust and does most of the work. And in this section over here, which is a simulation of the environment, what we see is that probably the most important part is to assign the reward to the actor decisions. And what we see here is that the reward is made of 3 parts. First of all, we give a positive 10 points for every step which is being done without violating the limits of the joint angle, which is specified here. Then we subtract the reward for not meeting the safety requirement. And the safety requirement, as we see over here, is keeping the center of gravity of the torso in between as close as possible to in between the center of the 2 feet. And then we have a comfort reward. And the comfort reward is the square of the sum of all the stops forces square. So this presents to you the process of development and reinforcement solution to improve our standard products. Thank you.